Okay, carry on. Sorry.
Okay. Yes, just saying that most of the stars' names are Arabic because there are no sort of reference points in the desert. So the Arabs obviously spend a lot of time in the desert navigating about. So they needed to know the constellations and the stars, and obviously they needed to identify the stars. This is why a lot of star names begin with Al. Al is just the Arabic word for the. That's why Aldebaran, for instance, means the follower, because it appears to follow the Pleiades when Taurus rises. It rises after they do. Um, but I also want to spend some time talking about the Polynesians because they also needed reference points because they spent most of their time navigating between islands, hundreds, sometimes even thousands of miles apart. Um, so there are not just the kind of Western traditions about naming stars, and in fact there aren't just the Arabic traditions either. There is actually one star. I don't know if anybody knows what it is. There is just one star in the sky that has an English name, and I'm not counting the pole star. I'm counting a one-word name. If anyone wants to know, I'll tell you at the end. There are Greek star names, Canopus, for instance. There are even a few Latin star names. Capella. Capella just means the small she goat in Latin. We also find some hybrid names made up. Well, I can think of one. The star Nuboatis is called Alcalurops. Now, there's that Al again, which is the Arabic bit, and there's that Kalorops, that's just the Greek word for a shepherd's staff, because that's what Boatis is meant to be. He's meant to be a herdsman, so that's his staff. So it's kind of a portmanteau star name, really. The other star I want to say a little bit about is Arcturus, which we call we call it Arcturus, don't we? That's actually another Greek name. The arct bit means bear. That's where we get the word Arctic from. That's where bears, i.e., polar bears, live. The Polynesians, or at least the Hawaiians, which is the sort of Polynesian group that I know most about, they call the star Hokulea, which means star of hope. Now, I just have a little picture of Hokulea here. There it is. This is a boat that some of the traditional Hawaiians used to sail across the Pacific in order to prove that it could be done even today. I actually volunteered to go on this boat. Didn't get around to it in the end, but you can just see the name there, Hokulea. There it is. That's a very important star for the Hawaiians because just a slight detour into a bit of celestial trigonometry, if you want, or at least geometry. By the way, no equations in this talk, so you're quite safe. It's a little known fact, but it is true, that relates to the relationship between your actual latitude and the declination of a star. So whatever your latitude is, any star with that same declination is always overhead. So for instance, for Norwich, which is about 52 degrees north, any star with a declination of 52 degrees north at some time is going to be directly overhead. Now, the latitude of Hawaii, or at least the Big Island, is about 19 degrees north, and the declination of Arcturus is about 19 degrees north. So when they were sailing, as soon as Arcturus started to get higher and higher and higher, they knew they were getting closer to Hawaii. Very clever. Now, a couple of pictures here. What is the link between these two pictures? On the left, we can see Canis Major. I'm not very good at drawing dogs. It doesn't look quite like a dog, but that's what it's meant to be. So there's Canis Major with Sirius at its top. To its right, there's a load of lava. Now, there is a connection between those two, and it has to do with the Hawaiian name for Sirius. Okay, there are two sorts of lava, and they both have nice Hawaiian names. The sort of ropey, smooth sort is called Paoihoi, but the sort you can see here has got another name, and that's called A'a. That is actually pronounced A'a. Because one of the letters of the Hawaiian alphabet only has 13 letters, so it needs all the letters it can get. There is a letter in the Hawaiian alphabet which is actually written. It's not written as an English letter. It's written as a backwards apostrophe. All right, and that's the glottal stop. That's the sound we have in ba'a. But in Hawaiian, that is an actual, bona fide sound of the language. In fact, it's very, very common. So the Hawaiian name for Sirius is also A'a, because the word means glittering, shining, which is what this kind of lava on the right is like. Now, for some reason, I can't see the bottom of my screen because the zoom bar is in the way. We have a problem here, don't we? I can't actually get rid of this bar. There we go. I've got rid of the bar. Right. So, it's come back again. So
What you can do,
that's all right.
you can
That's right.
if you
Yeah.
if you click on the bar, then while you hold down your left-hand button, you can move it to the side. I think you can.
Right. Okay.
I think you can do that. I thought you could. Maybe you can't.
Not working at the moment.
No, I'm wrong. You
Let's
can't.
try. No, I can't. Okay. Now this is where the funny story comes in. This is a picture from an 1822 star atlas by a man called Alexander Jameson. Now I'm going to try and not sound like the Monty Python Four Yorkshiremen sketch, but basically where I grew up, it was in a kind of a suburb of Great Yarmouth. And it was, if you'll pardon the cliche, it was a road of two halves. There was a sort of council half where all the oinks like us lived, and there was the half of the people that actually owned their own houses. Now, in one of the nice houses lived a man who I think he had a technical sort of job, but he knew I was interested in astronomy, and he had all these astronomy and science books that he actually gave me because he wanted to foster the interest. And one of the books he gave me was this 1822's. Well, it was a big star atlas. I mean, it was about a couple of hundred pages, and as you can see, beautifully illustrated. And not only is it beautifully illustrated, but it's illustrated with some constellations that we don't have anymore. There we are, Noctua, the owl. That's disappeared from the sky, even though its stars haven't. Of course, we can give names not just to stars, but to constellations as well. Now, the interesting story behind this is I was only about 10 at the time, and I had quite a strong artistic bent. Now, Mr. Jameson had these pictures coloured in professionally, but I got my coloured pencils out and I coloured some of the other pictures in as well, being only a 10-year-old kid. I eventually, I think, sold this to a local antiquarian for about 75p or 15 shillings, as it was at the time. And I since discovered the book has actually sold for £900. So that's a rather unfortunate tale of woe, I have to relate. But something interesting here is if you just look at the constellations, there are basically the sort of limit of the constellations follows the picture. Not very scientific, but that's how it was at the time. These actual sort of constellations weren't drawn down properly until about 1930. Now, there are various ways we can name stars. Obviously, we can't give them all proper names like Betelgeuse and Orion. There are simply too many. So, as you probably know, the standard the standard way of naming stars was to give them Greek letters. So the brightest star in each constellation would be Alpha, whatever, Alpha Hydrae, for instance. The second brightest star in that constellation would be Beta, and so on through the Greek alphabet. And that was in 1603 atlas that Bayer drew up. So that only accounts, because there are 24 letters in the Greek alphabet, that only accounts at best for about 24 stars per constellation. Now, obviously, there are quite a lot of stars in most constellations, more than 24, even naked eye stars. So we've exhausted the Greek alphabet, so we're now on to the slightly fainter stars, and we use what are called Flamsteed numbers. Now, the interesting thing about Flamsteed numbers is they weren't actually invented by Flamsteed at all. They were actually invented by a French astronomer called Lalande, but he used Flamsteed's atlas, so they're still called Flamsteed numbers. Basically, the way that works, you start off in the west, or the right-hand side, if you like, of the constellation with number 1, and this also applies to stars that already have Greek letters. So we can see here 1 Arietis, we're in Aries. He tells you where it is in Latin, which is in the preceding of the 2 horns. Now that's interesting because it assumes that all the pictures, if you like, are now standardized. So that's interesting in itself. And this is 1 Arietis, which also has the Greek letter of Gamma, which you may know is rather a nice double star, and so on and so on. It tells you where they are in the constellation, and it gives lots of information. We are moving to 100% kind of scientific stuff here now. So Ascensio Recta, that's right ascension, and this is Distantia Polar Borea, distance from the North Pole. So at this time in history, they're not giving declinations as in north or south of the equator. They're telling you how far it is from the pole star. And you've got lots and lots of information here. You've even got magnitudes. So we are now moving into not just giving stars names and for navigational purposes. We're now moving into actual science. So we've got the positions, we've got the magnitudes, we've got the names. Here we have Tycho. This is the number that Tycho Brahe gave it. Lots and lots of information. Now we are now moving from stars, pure and simple, into different sorts of stars, because after this people start to use telescopes so they can see lots of fainter stars, and they can also see that some stars are double. So now what do we need? We need a special naming system for double stars. This is actually a scan from my very old Norton Star Atlas, which, as you can see, is covered in variable stars. I told you I'd observe variable stars. But the interesting thing here is we are now looking at a part of the reasonably southern sky. Sirius is up here somewhere. Well, Sirius is about here. And here is, you have got Canopus here, but the thing here is in front of it. There it is, this Canopus. So quite a long way south. So Bayer couldn't see these stars because he was in Germany. So now when we go into the far southern constellations, we do have Greek letters to some extent, but we don't have the numbers. We don't have the Flamsteed numbers. Instead, when the Greek alphabet ran out, they named the stars using small letters. So here's A, H1, H2, V, and so on. But we have pi and sigma, so we have the Greek letters. But when they run out, we have English letters, if you like. And when they discovered that some of these stars were double, they thought, I think we should have a special way of identifying their various double stars. So astronomers, if they want to concentrate on double stars, because they were quite flavour of the month in about the sort of 18th, 19th century, think William Herschel and people like that. So people started to make catalogues of double stars, and they named these double stars as they were in their own particular catalogue. There was a whole family in, well, I think what is now Lithuania, but it was northern Germany at the time, or possibly Russia, called the Struvers. There was Otto Struve and either his son or his father, Friedrich. Not quite sure which one was which. But they made a big catalogue of about 300 double stars, 3,000 double stars. And because they couldn't use S for Struve, what they did, they used the capital Greek sigma, which is this kind of thing like an M on its side. So any star that has a capital sigma in front of it, followed by a number, that tells you that's a double star, and it's out of the Struve's catalogue. That has only recently, actually, been sort of superseded, and I'm not altogether sure that it was a terribly good idea. Because if we look at a slightly later version of Northern Star Atlas, here we have a bit of Cygnus. Now, there's a distinct lack of stars that start with a capital sigma. Because the people that did this is Norton's 2000, they simply indicated double stars by a star with a line through it. Now, that's really silly because the old Norton Star Atlas, as you saw, it had all the Struve double stars with that capital sigma. So you could tell it was a double star. Well, here, yes, you can tell there's a double star, but you don't know anything about it because Norton's doesn't just show the star maps on the facing pages, it has all the interesting objects. Well, you can't show an interesting object that hasn't got a name. So Norton's 2000, for instance, the double stars, only shows double stars that already have an existing, for instance, Greek letter name, because they've abandoned that Struve's catalogue. Now, I did a bit of research, and I actually looked at this particular star, and it turned out from looking at my old Nortons that this is one of Struve's double stars. It's number 2666, the number of the beast, more or less. But this, I say, this was a real drawback with Norton's 2000. Now, I said when we looked at the southern constellations that they used letters, English letters, after they run out of the Greek alphabet. But sometimes they would even run out of the small letters. So then they started using capital letters. And they finally exhausted the capital letters. That they didn't go beyond Q. Okay. So now we come to my area of interest, which is variable stars, because as you may know, in fact, earlier we were talking about T Coronae, that's a capital T. What people who now started to discover variable stars did was, these are special stars. You can't sort of give a variable star a Greek letter name because it changes in brightness. So what they did, because all those letters after Q were available, they started to give variable stars capital names. Here you can see R Cygni, and there's RT quite close to it, and there's AF and CH. CH is a really interesting variable star. You can observe it completely with binoculars, and it's one of the most interesting variable stars in the sky. Just to buy your buy there. Now, in fact, the system for naming variable stars is pretty complicated. It's actually more complicated than studying variable stars themselves. Really, how it works is, all right, the first variable star you discover here in Cygnus gets the letter R. The next variable star that was discovered is S Cygni, which is way off here to the north. And here you've got T, and here you've got U, and so on. Now, that's fine, because we then go through to Z. Z Cygni is sort of here, right next to this star here. What happens, because that accounts for 9 variable stars in each constellation. What happens when someone discovers the 10th variable star? Well, what we do then is we still go back to R, but then we have double letters. So the 10th variable star is RR Cygni, which is way up here. The 11th is RS, which is here, and so on and so on and so on. And you do that doubling of the letters all the way until until you get to ZZ. Okay, because after you go through the R, so RZ, the next one is SS. Now, SS Cygni is a very, very famous variable star. It's a bit like T Coronae, and it's right up here next to 75 Cygni, which is a lovely star itself. Here it is. There's 75 Cygni. It's one of the only stars in the sky that actually looks gold. It's a beautiful thing to look at, especially in a small telescope or a pair of binoculars. So we have SS Cygni, then that goes all the way through to SZ. Then we start with T, so T, T to T, and so on. But that whole thing accounts for 54 variable stars. What do we do then? Well, we go back to the actual start of the actual alphabet with AA, AB, all the way through to AZ, and then we do the same with the Bs, all the way through. But we stop at Q, obviously, because the actual variable star alphabet starts at R. So after QZ Cygni, which is about here somewhere, has been discovered, the next variable star, and we're a bit stuck there, aren't we? We've run out of letters. That system accounts for 334 variables in your constellation. The next variable star is really, really simple. It's just V335. Now that could literally go on forever, obviously. So that's how complicated naming some stars could be. Well, that was fine, wasn't it? This is the BD, which is the Bonner Durchmusterung. Durchmusterung is a nice German word. Germans love their big words. It basically means a gathering together. And this was done at Bonn, so it's called the Bonner Durchmusterung, or the BD for short. This was done by a guy called Friedrich Argelander, who some call the father of variable star astronomy. We're not going to go into variable stars anymore, you'll be pleased to know. But we still have to name all these stars because he made this atlas, and it goes down from the north celestial pole to about 4 degrees south, and it contains stars down to about magnitude 9 or 10. So you're talking about 250,000 stars here, which you clearly can't name by any sensible method. So what do? Well, he divided the sky up into 1 degree bands, starting at naught, basically the astronomical equivalent of the Greenwich line. So zero degrees RA. And then he started going east or left, if you like, in each 1 degree band. So here we've got a picture of the Pleiades, which are all more or less all north of 23 degrees. Now, he started counting in the 23 degree band way over here at 0 degrees RA. Pleiades are about sort of almost 4 hours of RA. So that's 60 degrees further. So you've already encountered a lot of stars in this 23 degree band. So by the time you reach Alcyone, which is here, brightest star of the Pleiades, that we call that, this is still a name, it's not a proper name, but the important thing, it's a means of identification. That's what we really mean by a name. So that's the 541st star in this 23 degree band. So we call it BD plus 23 degrees 541. And that system works for all the 250,000 stars in the BD. For instance, this star here, that's in the 21 degree band, so that's going to be called BD plus 21 degrees some number. That's how you identify each one of these 250,000 stars. Obviously, this only works north of the equator, so there's a similar method in use south of the equator, and it basically works the same. Right. We also have other catalogues. I mean, the catalogue I've used in the past is the SAO, the Smithsonian Astrophysical Observatory catalogue. That is basically a reworking of the BD. This here is basically a reworking of that for the sort of 20th century, if you like. It's now been superseded, obviously. Everything's on computer, much more easily accessible. I had the 4-volume set of the catalogue that goes with the SAO, and I ended up simply using them to prop the end of the bed up. That's a little bit sad for all the work that must have gone into it. But again, we can identify stars using their number in the SAO catalogue, which again starts at the North Pole and works south. So it's this particular star, Alcyone, is number 76,199 in the SAO catalogue. We have the Henry Draper catalogue, which is a catalogue of spectra, and it's number 23,630 in that catalogue. So again, identification. I really want to finish up with something that I often work with, which is the Gaia catalogue, because one of the things I do is I run the AAVSO sequence team, slight detour into variable star. In order to observe a variable star, you need to compare it with stars that aren't variable and whose magnitude you know accurately. And that's a list of those stars that will appear on the star chart is called a sequence, and I run the sequence group. We basically make sequences and star charts for stars that don't yet have any, and we've done that for the James Webb Space Telescope, for instance. So serious work here. This is actually an extract. Here we are. This is an extract from Gaia, which contains almost 2 billion stars. This is the previous data release. One that came out a few months ago contains even more stars and even more information. Now, in order to actually make a sequence for a given variable star, we need to know magnitudes, we need to know positions, and so on and so on. And even among those almost 2 billion stars, we can identify each one of them. In this case, the stars are actually identified by their positions. Okay, there is a Gaia number, but it's a very, very long number and it's very unwieldy. So it's much easier to identify stars here, basically to name them simply by using their positions. And here are all the gory details I'm sure you're not interested in, but they're the gory details that we need to make an accurate star chart with. And obviously, if you're working with people like the James Webb Space Telescope, they need accuracy. Just a little guide here. These E's, these are the errors. Error is a really bad word. It's got nothing to do with mistakes. What it is, it's a guide to how accurate this magnitude is. So as you can see here, this magnitude is accurate to 1/10,000th of a magnitude. Now that is accurate, and this is a sort of accuracy that you can get with surveys like Gaia. So we started off with calling Capella, for instance, the yellow star in the charioteer's left shoulder. That was fine for the time when you were navigating across the desert or crossing the Pacific. But now, when you're making charts for obscure variable stars, you need a slightly different way of naming the stars. But it is still basically the same thing. It is still identifying a star in the sky, and that's what naming is. So that's what we started with, and this is what we've ended up with. So I'm going to stop sharing now, and if anyone has any questions, you can fire them away. And I may be able to answer them, I'm not promising.
Well, thank you very much, Michael. That was fascinating. And as ever, we'll begin with a round of applause, which is difficult on Zoom, but either physical to the camera or a virtual hand clap. So thank you very much for that. There you go.
Right, thank you.
It's not quite the same, is it, as being in a room full of people, but there we are.
It's all right. I'm quite sort of used to it by now. That's all right.
Yeah, just going right back to what you said about your own background, interesting, linguistics. That's my background as well. I got a degree in modern languages. I didn't do linguistics per se, but there was a module which I did theoretical linguistics. So I know my John Lyons and obviously that,
Transformational grammar, yeah.
and de Saussure and Chomsky, of course, and all that kind of stuff. So I've forgotten all my morphemes and morphs and allomorphs now, but I
Oh,
loved
you
it.
must
I loved it.
don't forget your morphemes.
Yeah, I loved it at the time, I must admit. Yeah, I always kick off with a question and hand over to the floor. The RR system, I understood what you were saying about how they'd got as far as Q, so that left R available, but it had to be a double R because there was already a chance of duplication. So you only get 9 letters, and then you go uh, to the next nine. I'm just want to make sure I understood. They went from RR. When they got to RZ, they went to SS, not
Yes.
not SA, just SS, and did
No.
that until they came to ZZ. And then I think you said they went right back to A,
You go, yeah. Then
and
they
that
went back to the actual beginning of the actual alphabet. Yeah.
and did they then start with AA?
Yes, that's right.
I'm just wondering why with RR, why they didn't just do RA to Z and then SA to Z, because that would have, rather than just filling up those last 9 using double, they obviously, was there a particular reason why they wanted to use double letters the same, RR, SSTT, etc.?
Right. They didn't start with RR. They just started with a single R. So
Right.
RSTU all the way through to Z, and then you get the RR coming in.
Yeah,
Um,
the variables,
is
they started with the RR, is what you're saying.
no, the variables start with a single R.
Oh, I'm sorry. Okay.
So RSTUVWXYZ, and then
Yeah.
they went to
Yeah,
RR
but
because
that was just 9 though, as you said, yeah. But
yes,
then they went to RR. But why did they go to RR and not RA?
I honestly don't.
That's what I don't understand. Because
No, I don't know. I think actually probably it's lost in the mists of time why they did that. There,
yeah,
there, there must have been some reason for it.
yeah, yeah, and then they went right back to the beginning anyway, which they could have done. It's almost as though they cramped themselves up with the number of options with letters, and then
Yes,
got to the end and thought, oh, actually, no, we could actually go to the beginning anyway and start again. So I just find it a bit queer, but it's good that they did in a way because we have RR Lyrae stars, of course, which is a famous
yes,
category, isn't it?
yeah,
Which everybody
yeah,
knows as a candle star for measurements and things. Yeah,
yeah.
wonderful. Yeah. And the only other thing I was going to say, you mentioned the L in so or Al, I should say, in like Aldabran and etc., meaning the definite article in Arabic. I don't know any Arabic, but I suspect that the definite article is used a lot more in Arabic as rather than just for if but for quantifying things.
Yes, yeah. I think it might work slightly differently.
Yeah.
Yeah.
Well,
One interesting thing about the Arabic and also Hebrew Semitic languages, all their word roots are based on 3 different consonants. So, for instance, the sort of root consonants for things to do with writing in Arabic all go
mhm,
all go KTB. So you might have a word like katibu, which means library. You might have katab, which means a book. You
I
might
see.
have katabi, which means a writer, and so
Mm,
on. And
yeah.
all their words actually work like that. So if you see a star called for instance Deneb, and you see another star called Danab, you know they're basically the same word. I mean, Deneb actually means tail because Deneb
Yeah.
is
Okay.
yeah, it seems being in the tail of the swan. So that's how
Mm,
the Arabs saw it.
sure.
Um, but
I,
yeah, that's
I
just
did know, yeah, I did know that, of course, the influence of the Moors in Spain, 700 years, whatever. I know a little bit of Spanish. Italian and French were German and French were my languages at university. But I know that, for instance, the Spanish, the word cotton comes from the Arabic godon. And of course, the cotton would be algodon. and
Yeah.
the Spanish for cotton is algodón.
Ah,
And
yes.
as you and the definite article in Spanish is el if it's masculine. So if you
Yeah.
say the cotton, pick up the cotton in Spanish, that would be el algodón. So what they're actually saying is the cotton. It's a double definite article.
Yes. Oh,
But
yeah,
I digress. We've moved off from stars there. So anyway,
yeah.
yeah, absolutely fascinating, wonderful. So I'm clearer now with the RR system and why they did that.
But
Um,
it is horrendously complicated.
yes, yeah. 1.7 billion stars catalog. That's quite a
Yes,
spreadsheet, isn't it?
it certainly is. Yeah, I mean, fortunately, we only wanted a few stars.
Yeah, wonderful. Okay. Has anyone got a question about anything that Michael's been talking about tonight? I'm sure someone has. James, you usually
Yes,
take a lead.
yes. I've put my hand up, but you're not
Yeah.
looking, so I'll
I'm
speak.
sorry.
Um,
Sorry.
so
I,
yeah,
I'm a,
just a quick question. Thanks very much. Thanks very much indeed. That was really fascinating. But I think you said you were going to tell us about what the English star was.
oh yes, well
Ah,
remembered.
yes. Does anyone know? There's a really interesting story behind it. This star name only dates from 1930, and it has to do with the RAF. Now, apparently, RAF navigators have to have names for all the stars that they use to actually navigate by. But there were a couple of stars in the southern hemisphere that didn't have names, because obviously, the Arabs and the Greeks and so on gave the stars their names, and they couldn't see terribly far south. Um, so the I think it was the government body that ran the RAF. I can't quite, but I mean, I used to work for the government. I can't remember what they're called. Anyway, basically, the RAF used this manual that they call the Air Almanac, and that included names of all these stars that they needed to navigate. And two stars in the southern hemisphere didn't have proper names. One was Epsilon Carinae, which, if you know the southern sky, is one of what's called the false cross. It's like the Southern Cross, but it's bigger and not quite so bright. That star didn't have a name. Now they call that star Avior, Avior, obviously related to aviation and so on. But the other star was Alpha Pavonis in Pavo, the peacock, and they decided to call that star Peacock. That's the only star in the sky that has an English name.
Ah, so it's called Alpha Pavonis. The Alpha in the Peacock constellation is Peacock. Oh,
Yeah, yeah,
interesting.
and that's the only English star name.
Thank you.
So Avior counts as is that presumably Latin really, is it? Or
Well, it's a sort of a Latin root, isn't it?
yeah, like aviator. Yeah.
Yeah, yeah.
Okay. Yeah, sorry, Neil. Well remembered. We all forgot, including our speaker, that the riddle we were given.
Yes,
So now we know. Peacock, that's good. Yeah.
and
Yes.
you can now say in the purported words of Michael Caine, not a lot of people know
No, no.
that.
Very good. Yeah, I mean, obviously with the craters of the moon, there aren't as many craters on the moon as there are stars in the heavens, but once we started naming craters, I mean, we started with the Greeks, there's, all of the famous Greek philosophers and obviously astronomers. And then since then, I mean, there is now a Patrick Moore crater, I'm sure,
There
and
is, yeah.
other things. But as far as I know, there are very, very few. Are there any stars that are named after people that we know of? I
Ooh,
can't think of any.
not not that I can think
They've
of.
they've
Well,
all just
Barnard's star and that kind of thing.
well, I discovered, yeah, that's true.
Hmm.
Barnard Star. Yeah. There might be a couple which are named after discoverers or people have given. Yeah.
Wolf 359 and Gleason
Yes.
1228.
Yes, well,
That's
there, of
very
course, we're back to the catalogues
mm,
because I mean he drew up basically a catalogue of red dwarfs, which is what Wolf 359 is.
okay. But by and
But
large,
it's also a variable star. It's called CN Leonis.
okay. Interesting.
But, this is kind of what I was talking about with the sort of Flamsteed and and that catalogue that Monsieur Lalande used, because he identified the same star, but by three different things. He identified it with its Greek letter, and he also identified it with the number, like 1 Arietis, which is Gamma Arietis. So you have more than one name for the same star.
Mm. I suppose it's too late to achieve some kind of grand realignment and renaming of all the stars. It would cause even more confusion now, but it has become over the centuries, over the millennia, a bit of a mess because of early astronomical observations and nomenclature. So we end up with what we've got today. It gives it a certain charm, and it's fun. I mean, if all the 3 billion stars or whatever it is we might have catalogued were numbered 1 to 3 billion, it would be pretty tedious and boring, wouldn't it? So I think we should be grateful for what we've got, but it is a bit messy. But thank you for adding some light and some clarity on that. It's a fascinating topic. Anybody else with another question before we close? Anybody?
Well, it's not somebody else, it's me again.
That's all right. No, go ahead. Go ahead, Neil.
Yeah, I just wondered, thanks, Michael, a couple of things. We've got these official boundaries, IAU boundaries of constellations. So do any of the star references with Greek letters, numbers, etc., variable names, do they fall in the wrong box for some reason of history? Or are there any that are in a boundary of a different constellation but seem to be called after another one?
Well, this is really interesting actually, because you'll be surprised to know I went back to variable stars again. There's actually it's a star like T Coronae, and it's another T. It's T Leonis. But T Leonis is right on the border of Leo and Virgo. And because of the precession of the equinox, it kind of moves the lines in the sky about, T Leonis is now in Virgo, and it's called QZ Virginis. So that's exactly what has happened.
Oh, okay, that's good.
So it's not just changed its variable star name, it's changed its constellation name as well.
Yeah, what used to be Alpha Pegasi, I think the northeast corner of the square of Pegasus. It's
Yes.
now part of Andromeda. It's moved. So technically, the square of Pegasus has a star in it, which isn't in Pegasus.
Yes, that's right.
I think that's right.
Yeah, when they reorganised the constellation boundaries in 1930, Alpheratz, which is the star you're talking about,
that's right. It's Alpheratz. Thank you.
It's now Alpha Andromedae. Before that, it was Delta Pegasi.
Delta Pegasi. Yeah.
And they reorganised the boundaries, so that star is now in Andromeda.
Yes. Thank you. I couldn't remember the name, Alpheratz. Yeah.
Yeah, it's still called Alpheratz.
Yeah.
Is that where some of the constellations you had in your that drawing you showed earlier, when you said, well, it's no longer in existence? Is that when some of those disappeared, or was that earlier? Or was the one like the owl or whatever it was in the drawing?
Actually, what used to happen with all those old guys, that sort of brought out their own star atlases. Basically, if you brought out a prestigious star atlas, you put your own constellation in it. That was kind of
right.
That was kind of marking your manner, if you like. And that's what Jameson did. He actually put because that Shuyu part of Hydra, which is it's the biggest constellation in the sky, very, very long, goes basically all the way from sort of Cancer right through to Libra. He put another of his inventions on the coils of the snake, if you like, and that was Felis the cat, not Felix the cat, but actually Felis, isn't it? Because I'd have my Latin master after me for mispronouncing it. Felis the cat. But they've both disappeared. In fact, for a few months' time, I'm going to be giving a talk on that very subject, dead constellations, if you like.
Yeah. And some of them were chopped up and renamed, so they actually increase. I mean, Navis, the ship, I think we've got today Puppis and Carina, and I can't remember the word for compass.
Vela is the other one.
Sail is the sail. That's the sail, isn't it? And then
Yeah.
there's the compass. What's the compass? Can't remember.
Pixis.
Pixis, thank you. So
Yeah.
they're all existing constellations post 19, whatever it was, the conference, the big IAU conference that fixed the 88 constellations we have today. But Navis itself, I think, is now defunct. So it was kind of broken up. Am I right?
Yeah. I think the general sort of consensus was that it was simply too big.
Yeah.
So they just
Too big, but of course they've increased the number of constellations by 3 or 4 by breaking it up.
Oh well, yes.
Yeah. Actually, just one final question. Has anybody else got a question? Okay, it's leading on from what Neil was saying about the boundaries and things. What about, and if we go to the very latest catalogs where they are so accurately measured and named and given, so we saw in that Gaia list we have, right ascension down to 10 decimal places or something.
Yeah.
And although it's not very pretty or romantic, it makes sense to use a very exact RA and deck to give it a designation, because the more accurate it is, the less likely you are to have two stars superimposed. They can always be split ultimately. Although I guess somewhere in a line of sight there's going to be a perfect alignment. But aside from that, what about stars nearby? What about stars that exhibit proper motion? What about stars that are moving? And if we're measuring to that degree of accuracy, that will change over just a matter of a couple of years. How is that? And that they may even drift in and out of a I don't know whether they're moving that much to be able to do that, but there might be some stars that are actually changing. They're certainly changing their position, but they might. How do they accommodate that?
Again, this is quite strange, because actually last week I was giving a talk on that very subject again.
Okay.
I was giving a talk on what are called runaway stars. These are stars with very, very high proper motions.
That have had some cataclysmic ejection or something, and yeah.
Well, possibly. That's usually the case. It actually normally happens when stars are born, which is, that's my sort of field. But the granddaddy of those stars is Barnard's star, which someone mentioned earlier.
Yeah.
And the reason that's moving so quickly is because, it's the second closest star to the sun. So it's moving. It appears to be moving quickly simply because it's so close, and it is genuinely moving a bit quickly than the most of the stars around it anyway. So that that just adds to it. It's moving north, and it's still going to stay in Ophiuchus, but give it a few thousand years, and it'll probably be in Hercules.
It will drift. Yeah.
But really, what happens with a lot of those stars is they're virtually all red dwarfs. So they will all have red dwarf names, like Wolf 359, for instance. Or in the case of Barnard's star, it's a variable star, because basically all red dwarfs are variable stars. They're usually what are called flare stars. So they show huge flares, like solar flares, but of course they're much, much smaller than the sun, and the flares are bigger, so they're pretty cataclysmic things. Barnard's star has actually got one of these variable star names. It's not letters, because Ophiuchus is a big constellation near the Milky Way, lots of stars in it. It's called V2048 Ophiuchi. It's a 2048th variable star to be discovered in Ophiuchus.
Wow.
So that's how we can identify it. But as I say, it's also called Barnard's star. Yeah. It will have an entry in the SAO catalogue because it's about magnitude 9. It will obviously appear in Gaia and all sorts of places. This is why in these very accurate catalogues, you always give the date when the positions were actually measured.
Yeah.
For instance, that old copy of the SAO catalogue I had all the positions were for January the 1st, 1950. And now,
Yeah.
obviously, all positions are for January the 1st, 2000. Now, as we're going to start moving through 2025, then 2050 is going to loom large. So I don't know if the positions will then be updated to what they're going to be in 2050 or not. But there'll always be some method of identifying.
Sure. I mean, for all practical purposes, for most of us who aren't engaged in identification at such or positioning at such a precise level, it doesn't really matter on a human scale. And,
No.
and by human scale, I mean a lifetime or a couple of centuries. But
Yeah.
if in the very long term, of course, if you think about precession and how the pole star will no longer be the pole star, and give it another 15,000 years halfway through our next cycle or whatever, it's all going to change again. But we don't have to worry about that just yet, do we? For 15,000 years.
No, but there was one star which, even in the sort of 17th century, I think it was, they knew it had changed its position, and that star. Yeah, we talked about that star earlier, and that is Arcturus. They could see from very old, I think, Arabic star charts that the position of Arcturus had changed
in just a matter of a few hundred years.
Yeah. That's because Arcturus is, well, it's a bit like Barnard's star, but obviously it's not so close, but it's fairly fast moving, and it's fairly close. It's about 30 light years away, which I know in everyday talk isn't terribly close, but it's quite close astronomically.
Relatively speaking, it's our backyard.
Yeah.
Fascinating. Okay, I think we're done. I'm going to say rien ne va plus. Right. So once again, can we give Michael a very big thank you and a round of applause, virtual or otherwise. Thank you very much, Michael. It's fascinating, and I hope to be able to invite you back again another season sometime for something else.
It'll be a pleasure. I'll probably be talking about variable stars.
Well, that would be fine. Okay. We have one more meeting, folks, next month, and then it's the end of the season. I say the end of the season. Yeah, goodbye. Thank you, Michael. By all means.
Thank you.
And we have one more meeting next month, and then we take a month off. We'll have a quick meeting, James, with the future plans and things.
Yep.
And we'll see you all again in September. And September will be our old friend, who's coming back again, Steve, what's his surname? Steve Barrett, and he's going to talk to us about the 200-inch mount, the Palomar 200-inch Hale telescope, and that will be at the Kindle. Okay.
Will it? I haven't booked anything.
Oh yes, sorry. We did. Yeah, sorry. Yeah,
unless you booked it.
No, but our first meeting. Sorry. We've still got time, I'm sure.
Yes. Yeah. What's the date of that?
Well, whatever the first Thursday is in September.
First Thursday. I shall get on that and send a booking.
If the worst came to the worst, just put it back a week or something. Or
yeah. First Thursday.
Steve, in
September.
That's a kind of blanket booking.
Yeah.
That's a given.
Yeah,
well, I think we're only just into July. We should.
Yeah. There's plenty of time. Usually it's about 2 or 3 weeks ahead.
And the usual place, the queue room.
Queue room. Yeah.
Okay. All right, everybody. It only remains to me to say have a happy holiday if you're going anywhere soon between now and next week, next month. If not, I will see you in July.
Thank you very much. Cheers. Bye-bye.
Bye. See you. Bye.